Okay, now on to number 11 through, we'll go up to 16. Number 11 through 16, let me help you with those questions. You could try these first, and then if you need help, you could skip to the question, the parts of this video that you may need help with. Number 11, okay, the question is using this graph right here, this particular graph defined by the piecewise function on the bottom left corner of page 84. But you, in any case, okay, you could just start with this graph. You don't really have to worry about those functions. The first question on number 11 is asking, does f of negative 1 exist? Okay, so is there a defined y value at x equals negative 1? And the answer for that is yes. That defined value is 0. F of negative 1 is equal to 0. So 11a, your answer is yes. Okay, the question B, does the limit of f of x as the x approaches negative 1 from the right side, does that exist? Okay, once again, let's take a look at my highlighter right here. Okay, so we're approaching negative 1 from the right side. Does the limit exist from the right side? Yes, it does. Okay, that limit happens to be 0 as well. Okay, and the next question, okay, does the limits of x from that approaches negative 1 from the right side, does that equal to the defined value at negative 1 for that function f? The answer is yes, because both values are 0. Okay, that's number 11. So the question D is f continuous at x equals negative 1? And the answer to that question is yes as well. You could say that this is continuous from the right side. Okay, with the same graph, that you have, let's answer questions number 12. Questions number 12 and 13. Number 12, does f of 1 exist? Okay, yes it does. Does the limit exist at 1, near 1, as x approaches 1? It does. Okay, if you see the left limit and the right limit near 1, they coincide. So the limit, so let's write a proper notation for this. The limit of this function as x approaches 1 is equal to 2. The y value near 1 from the left side and the right side is equal to 2. Okay, but okay, the previous answer to this one, the defined value at 1 happened to be 1. F of 1 is 1, but the limit at 1, limit near 1 is 2. The limit as x approaches 1 is 2. So you could conclude that at x equals 1, the function f is not continuous. So number 12, C and D, the answers are no. Number 13 is f defined at x equals 2. I think you could answer this now. Okay, so the answer obviously for 13a is no. B is f continuous. No, it's not. You don't even have to check the limit because f is not defined at 2. Okay, so with the same idea, I want you to try to answer 14, 15, and 16. And on the next video, I'll go on to number 25 through 28, those kind of questions.